Good morning, students. Today we are going to see about nonlinear data structure, graph traversal techniques, depth first search. So the objective of this presentation is we are going to learn about two different types of traversal techniques. One is breadth first search, the other one is depth first search. In the last class we have discussed about breadth first traversal algorithm. So in this class we are going to discuss about depth first traversal algorithm with an example. So what is graph traversal algorithm? Hope you remember, traversing is nothing but visiting all the nodes. So we have two standard methods for graph traversal. They are breadth first search, the other one is depth first search. What is depth first search algorithm? Okay, so it is a recursive algorithm. It is used to search all the vertices of a graph or all the vertices of a tree data structure. So how this algorithm works means it begins with the starting node A, and this A becomes the current node. Then you have to process the neighbors of A, then a neighbor of A, and so on. Okay, so like that, for each node we are searching for its neighbors in depth wise. That's why it's called as depth first search algorithm. During the execution, if we found that a particular node is processed node, then no need of revisit again, just backtrack to the current node. So if the node is not processed, then you can make that node as the current node. Okay, so the same process is repeated. The algorithm for depth first search is like a breadth first search. Here also I am using the variable called status. So the status is initially set to 1 for all the nodes in the given graph. So status equal to 1 indicates that the node is in ready state. I told you have to push the starting node A on the stack initially. That is, it is the current node now. So we have to set its status as 2. So status equal to 2 indicates that the node is entering into the waiting state. Then as the breadth first search, we are going to repeat step 4 and 5 repeatedly until all the nodes are processed. So you have to pop the top node. Since this is a stack, always the last node is popped out, the topmost node is popped out, the topmost node is processed, and its status is set as 3. So status equal to 3 indicates that it is a processed state. After popping out the node n, you have to push all the neighbors of n into the stack. So instead of queue, in depth first search, we are using the stack data structure. While pushing the neighboring nodes, we have to check their status is 1 or 2. Okay. So if the status is 1, then you can push that node into the stack and you have to make that node status as 2. If status equal to 3, then you don't need to push that element into the stack. So that's about the algorithm for depth first search. So we are going to see with one example. Consider we have a sample graph and its adjacency list is also represented. So they ask you to print the depth first traversal of all the nodes from the node height. So here the starting node is height. So in the first step, height is initially pushed on to the stack. So you have to pop the topmost element from the stack. Since we have only one element, it is the topmost element, that is height. So height is popped out and it is printed. After that, you have to push the neighbors of H to the stack. So what about the neighbor of H? It is A. So A is pushed on to the stack. In the next step, since I am having only one element A in the stack, it is popped out, and after popping the element it is printed, and after printing the neighbors of A, that is B and D, are pushed into the stack. Now the stack contains two elements B and D. So here the topmost element is D. So it is popped, and the popped node is printed, and we are seeing with the neighbors of D. So the neighbors of D is having only one neighbor F. So F is pushed on to the stack. So now stack contains B and F. So can you tell me which element is going to be popped out next? The stack is containing the elements B and F. So we have to pop the node F. Okay. So the node F is popped, and after that the popped element is printed, and we are seeing with the neighbor of F, it is A. So already A is the processed node. So you don't need to reinsert them. You don't need to push that element again into the stack. Okay. So see the figure. So print A. A is a processed node. So you don't need to again push that element into the stack. Okay. So now the stack contains the element B. So B is popped, and after popping the node B, it is printed. After printing, we are seeing the neighbors of B. It is C and F. So already F is printed. So only we have to push the node C into the stack. So now the stack contains the node C. In the next step, so we are popping the topmost element C. It is printed, and we are seeing the neighbors of C. So C is having the neighbors E, G and H. So H is our initial node. It is already processed. So the unprocessed nodes E and G are pushed on to the stack. Now again, pop the topmost element from the stack. So it is G. So G is printed. See the neighbor of G. So the neighbors of G are E and H. So H is already processed and E is already in stack. So you don't need to reinsert them. Now stack contains only one element E. So that element is popped out and it is printed, and we are seeing the neighbors E, B and F. Both B and F are processed nodes. So you don't need to insert them into the stack. Now the stack becomes empty, which means that all the nodes of the graph have been visited. So you can print the sequence of the graph. So in which order we have printed. Okay. So at first we have printed the node H, then A, then D, F, B, C, G, E. So this is the depth first traversal of the given graph. So what are the applications of depth first search algorithm? So it is used to find a path between the two specified nodes U and V for both the unweighted graph and for the weighted graph. It is used to check whether the graph is connected graph or not. It is used to compute the spanning tree of the connected graph. So these are some applications of depth first search algorithm. So these are some Anna University sample questions, and these are some sample gate questions. So this is very important topic in nonlinear data structure graph. Okay. So once again, so depth first search is nothing but it is one of the graph traversal method It is a recursive algorithm. It is used to search all the vertices of the graph. So here the neighbors of nodes are visited in depth wise in order to find the depth first traversal. Okay, thank you all.